Hey everyone, welcome back to Simple GAN, where we make engineering simple and fun. Have you ever wondered what's inside a centrifugal pump and how it actually pushes water with such force? Well, today we're diving deep into the components of a centrifugal pump and how each part plays a vital role in its working. So, stay tuned till the end, because by the end of this video, you'll be able to visualize exactly how a centrifugal pump works, from suction to discharge. Let's begin with the basics. What is a centrifugal pump? A centrifugal pump is one of the most widely used pumps in industries, water plants, irrigation, and even chemical systems. It works on a very simple principle: the conversion of mechanical energy from a motor into kinetic energy of fluid and then into pressure energy. The heart of this pump is its impeller, which spins at high speed and throws the fluid outward, just like how water splashes out when you spin a bucket full of water in a circle. Now let's break it down and understand each component one by one. The casing is the outer shell that holds everything together. It is designed to collect fluid from the impeller and convert the kinetic energy into pressure energy. There are mainly two types of casings: volute casing and diffuser casing. In a volute casing, the spiral-shaped design gradually increases in area, which helps in reducing the velocity and increasing pressure. In a diffuser casing, there are fixed guide vanes surrounding the impeller that direct the flow smoothly, minimizing losses. Think of the casing as the muscle of the pump. It's what turns velocity into usable pressure. Next, the impeller, the most important part of a centrifugal pump. It's a set of curved blades mounted on a shaft, connected to the motor. When the impeller rotates, it throws the liquid outward due to centrifugal force, creating a low-pressure area at the center. This is what draws more fluid in, and the cycle continues. There are three types of impellers: open impeller, used for dirty or viscous liquids; semi-open impeller, for medium clean liquids; closed impeller, for clean and clear liquids. So, in short, the impeller is the heart of the pump, converting mechanical energy into fluid motion. The shaft is what connects the impeller to the prime mover, usually an electric motor. It transmits the torque needed to spin the impeller. To protect the shaft from wear and corrosion, especially in the sealing area, we use a shaft sleeve, a replaceable protective covering. You can say the shaft is the backbone of the pump, while the shaft sleeve acts like armor protecting it from attack by the fluid. The suction pipe brings fluid from the sump or tank into the eye of the impeller. For smooth operation, the pump casing and suction pipe are always filled with liquid. That's why priming is necessary before starting. If the pump isn't primed, air pockets can stop suction and cause cavitation, which can damage the impeller. So, always remember, a centrifugal pump hates air. The delivery pipe carries the pressurized fluid from the pump casing to the discharge point. A delivery valve is fitted on it to control the flow and to isolate the pump during maintenance. Simple yet crucial. This is where your pump's hard work finally pays off. Bearings support the rotating shaft and reduce friction. They ensure smooth, vibration-free operation. The bearing housing holds the bearings in place and sometimes includes lubrication arrangements, either grease or oil. If bearings fail, the pump starts making noise, vibrates, and performance drops drastically. Now, where the shaft enters the casing, fluid tends to leak out. To prevent that, we use either gland packing or a mechanical seal. Gland packing uses soft material tightened with a gland follower. Mechanical seals are more advanced. They use two polished faces that prevent leakage even at high pressure. So, in simple words, the mechanical seal is the leak protector of your pump. The coupling connects the motor shaft and pump shaft. It allows easy disconnection for maintenance and ensures smooth power transmission. Now that we know all the parts, let's see how it all works together. 1. The pump and suction line are first primed with liquid. 2. When the motor starts, the impeller rotates rapidly. 3. Fluid enters the eye of the impeller at low pressure and gets flung outward by centrifugal force. 4. As it moves outward, velocity energy is converted into pressure energy inside the casing. 5. The fluid then exits through the delivery pipe at high pressure. This continuous process maintains a steady flow as long as the impeller rotates. And that's the magic of the centrifugal pump. Simple design, yet extremely effective. So, to summarize, the key components of a centrifugal pump include the impeller, casing, shaft, bearings, seals, suction, and delivery systems, all working together to move fluids efficiently. If you found this video helpful, give it a thumbs up, share it with your friends, and don't forget to subscribe to SimpleGAN for more easy engineering explanations every week. Until next time, keep learning, keep engineering.